Okay, so this is the final video for the block code stuff. Um, I've gone over mostly everything that was in the scope of this training thing, but just for the sake of if anyone decides to delve further into the block code stuff and wants to do a little bit more deep understanding of how you can use the block code in unique ways, I'm going to go over, briefly go over each section, and then also a place where you can visit that can help you get better information about it as well if you decide to look into it more. So first we have this motion section, right? And it's mostly stuff about just motors and yeah, like spin, set the position, set the velocity, brake, torque, how long can it be spinning for, how much power do you want to put into it. So that's pretty much what motion is. Switch looks rather interesting. I'm not 100% sure what it does, but there's a concept of switches in text-based code as well. And if it is referring to that, I honestly say that don't worry about it, because you may or may not be able to use these switches at all. There might not be a functional purpose, at least for our robotics sake. But if you want to look into it, you can go to the website. I'll show you at the end. Then there's this looks section, right? This is about printing stuff or putting stuff onto the brain mainly, or to the controller screen as well, by the way. So there's print, set cursor, print position is also here. I don't really know exactly what it's for, but it sounds like it's just going to be about having it printed at an exact location, which I think is pretty obvious. But yeah, then there's clearing rows, clearing your screen a little bit, changing the font. Then there's drawing, which is like drawing specific pixels, so dots, drawing a line with these specified numbers, rectangle, circle, pen width, so thickness, color, background color. Then there's these extra small things like a rumble. There might be more if you have different devices perhaps. There's the LED, and also all of the other options you'll get when you select any other I/O devices. I/O devices are input-output devices. So, then there are events. So when my robot starts, when my program starts, when this program is selected on the brain, I wanted to do some specific code, such as saying code started, or maybe setting my motors to a particular position. Then there's also when autonomous. So during the autonomous period, it'll automatically run this. It's the way the brain works is that when the when the plug is connected to your controller at the competition, it sends a signal to your brain that I want to run this area of code. I want to run this thing called autonomous, and that the thing here that says when autonomous, that's what defines that section. And you'll see it's something like that for text code as well. You'll use something called a function for when you do it in text code. But here, these are just referred to as events. So when started will automatically run when you start the program. When autonomous will run when autonomous is called from either the competition environment or in the other way by going through like timed run and stuff. And then there's driver control and other controller events, as well as the brain being pressed or the timer, which by the way I forgot to mention, timer is just the built-in clock of the brain. So yeah, it's the way the brain knows how much time has it been since I started this program. It's like that timer that it has, or stopwatch maybe is a better way to refer to it, since the beginning. So when like 10 seconds into the program have started, once I've been 10 seconds into the program, maybe I want to change the position of the motors or something is all I can think of. And now there's also these message related stuff. I have never used messages before, these message things, but I'm pretty sure they're similar to what I said earlier. When the brain receives some sort of signal from that wire that you connect your controller to at the competition, that signal is a message. So I'm pretty sure that is probably what it's talking about. Broadcast is going to be sending that message. And then broadcast and wait is going to be sending that message and waiting for a reply or some sort of signal back. Then these other events might pop up when you add more I/O devices, input-output devices, such as optical sensor or distance sensor. So now there's also control structures. I mentioned this in another video. There was the wait thing. Wait is going to be used pretty often. There are these different types of loops, like loops based off a specific number of times to repeat, loops that just keep infinitely repeating until you use a break block, then condition-based loops over here. Also, condition-based loops are while loops. Condition statements are if else, and elif is else if statements. Wait until, I think, is just going to be wait to do something until some sort of condition is met. Break, as I mentioned, is to break out of a loop, or also you can use break to break out of this type of if else structure. Now there's also stop project. It means you'll just terminate your program, end the program and just like stop running. The next section is sensing. So in sensing, there is this timer, right? You can reset the clock that the brain uses to be back to 0 seconds whenever you want, if you wanted. Then there are also these things. These are arguments, I believe, and it essentially is going to give you this information. So if I say I want to print the timer, I can put that instead of some sort of actual text. And of course, other things that are circles or ovals are going to be the same. So if I put the brain cursor row, it'll print what cursor row I'm on right now. Then there's also this event one that you can use in like condition statements. Controller sensing, so based off buttons. I guess there's also this disable and enable option. You probably won't be using it because you only have one controller in our games. This is a pretty powerful thing, being able to sense the location of your motor. Now, you'll realize once you use it that this is actually very inaccurate. And even when you do set position, it's pretty inaccurate. So rather than using the motor's built-in understanding of what position it's in, you should actually use the an encoder. You should use an encoder. Hang on, let me see where it is. Yeah, so this thing called an encoder, you might see it around the classroom, or yeah, and this detects the position of the axle that it's on, and the axle obviously will be connected to your wheel, which will be connected to your motor. And when your motor spins, this thing still stays in position, but that center small dot thing you see, the axle will spin, and it'll detect how much it's spun and to what position it's spun. And this thing is a lot more accurate than the built-in motor thing. So if you add this device, it might, there we go, it'll give you a few more options for it. Yeah, and this thing will print what the current of the motor, how much current it's consuming while it's running, and same for the other ovals, like the temperature it's currently at and stuff. So actually using this could be helpful to see if your motors are overheating as well. Then there's different types of not events, but arguments, I guess you can say, or commands you want to have happen based off your I/O devices. So again, when you add a certain type of device, the set commands will show up only then. So even though I want a gyro option exists, the commands that I can use with the gyroscope won't show up until I actually select it as a device and give the ports. So that's why encoder started showing up only now. So encoder is just going to be set the current understanding, like the current understanding of the position that the axle is at. Pretend like that's 0 degrees now. That's essentially what you're telling it. This will actually tell you what the current position of the encoder is at. This will tell you how quickly it's spinning. I don't know what DPS is, but RPM is rounds per minute. Then there are optical sensor stuff. Again, most of these are not too complicated, but yeah, this is going to set the light, I believe, to be some color. I'm not sure. This is going to set the light of the optical sensor on or off, change the brightness of the light. This is going to be detecting if something has been seen, or if a color has been seen, or if a gesture has been detected. So if something has moved up from the optical sensor to the left or to the right, then yeah, mostly what that stuff is. Then there's also digital out sensing. Digital out, again, as I mentioned in the first video, is referring to the pneumatics. Digital out, well, digital out can be other things as well. No, actually I take it back. Yeah, digital out is generally your pneumatic. It's your solenoid. It's actually connected to your solenoid. Yeah. Now there's also these operators. Operators just go inside your conditional statements. So if you have like an if loop, or if you have like a else loop or something, you might use and or not. Not, by the way, I had mentioned earlier, right? If the object has not found an object, then do all of this stuff. So it's the exact opposite of whatever this statement is. Usually it would be like, oh, if the optical sensor finds an object, then do this stuff. But I actually want to use not, which means if the optical sensor doesn't see an object, then I want you to keep going through this. That's what the not is for. Pretty useful, actually. And then there's these. These are just like, it tells you, oh, what's 0 times 0? Or, of course, you could change the numbers to be like 2 times 4 or something, and you get 8. Or these other operations that you can use, like absolute value, or you can search up what these others mean. Variables, I again don't think you'll really be using it a lot because you're doing block code, and block code really won't, unless you're really trying to make your robot amazing by using block code, you probably won't use variables. And if you're trying to get your robot to be really powerful in different unique ways, then I suggest you just use text code instead. But if you wanted, there's this thing called a variable, and a variable is just like, you know how in math you have like solve for x, right? And x is some, in reality x is some number, right? In this case, it's like you're saying, okay, x is equal to 5. I always want to say x is equal to 5. So now when I do y equals x plus 3, I'm actually saying y equals 5 plus 3, because I already said x equals 3. So I'm just saying, sorry, x equals 5, yeah. So that's what variables are. Booleans are a type of data type. I'm not really going to go into that because this is block code, but yeah. There's also comments. They literally do nothing except for working as documentation. So if I want to say the code above, or rather the blocks above, occur when the program starts, it doesn't actually functionally do anything, but as a user, as someone who's programming, right, if you want to see what does this code do, rather than trying to go through each line of code and understand what it's doing as a whole, you can just read this documentation or write the documentation so other people can understand it quickly. Yeah, so those are pretty much all the sections in here. Now, if you want to go in depth on one of these sections, or if you want a better explanation than I gave for one of these, you can go to this website. I'll link it on the Canvas page. But if you do want to find it anyway, you can do api.vex.com/v5/home/blocks/index.html. And here you'll be able to find all these options for the different sections. So motion was all the options, right? It gives me all of these different motors. Motor 393 is a special type of motor. Motor 55 is another special type of motor. And yeah, the smart motors are the ones we always use. And then of course there are these other options, such as like if you want to go to events and you want to understand what the broadcast stuff is, right? Broadcast. Yeah. So this is a great website to find stuff, to understand stuff. It has pretty decent explanations and images. And yeah. Now, one last thing I wanted to say before I end this is that block code does work functionally to some degree, and for the basic bare bones of your robot, it will be fine. But if you really want to have like a good working robot that has like a good chance of being slightly better than maybe other teams' robot, you might want to use text code rather than block code, because you might not have noticed, but block code actually has a lot of limits. There are a lot of missing functionalities in here. For example, in Python code, you might be able to, um, well, I can't really think of an example right now, but there are definitely a lot more options. Oh yeah, in Python code, you probably are able to add a photo onto the brain if you want. That's like one of the nice perks that you get from being able to use Python code. But something that you don't get that's in Python code that's even a bigger deal is the control over your motors. So right now, right, you have to select a motor group, call it whatever, and select its controls with this or by setting it up with one of these event-based occurrences. But if you use Python, right, you can decide that I want to change reverse and forward at the click of a button. So if I want to say the front of my robot is now the back of my robot, as from a user standpoint, from the driver standpoint, you can literally just press a button and boom, you switch the front and the back. And that makes going in reverse like 10 times easier. That's something you definitely cannot do with block code. So yeah, I suggest if you're really planning on investing into your robot and trying to make it good, you should go for text code. Whether it be Python or C++, up to you, but anything's better than block code in my opinion. But yeah, as a beginner though, if you have no code experience, I think it's perfectly fine if you use block code for your first time and if you've never coded before. Yeah. Again, functionally, everything in block code will work to do the basic bare bones things that you need your robot to do. For example, moving forward, backward, detecting things, um, being able to turn, being able to change the state of a pneumatic, like open or close, stuff like that. Everything that's basic is already capable of being done in block code, but it's like the control you have over what can be done is a lot greater in text code rather than block code. So yeah, I strongly encourage you to try text code once you get a little bit familiar with how block coding works. Yeah. Okay, bye-bye.